All right, so for this first one, we're just going to do it individually. You did not have to do the second one. So we are going to do this one individually and this one individually. For the left one, we want all of our variables to one side, all of our numbers to the other. So I would probably subtract this way, subtract my y over. If I canceled y's on the left, then I need to cancel numbers on the right. All right, and once I've canceled numbers on one side and variables on the other, then I'm just going to add down. 9 minus 7 is 2. Bring down my less than sign. 4 minus 3 is 1y. And then I am going to do this second one. The second one's a little more involved. The first thing I'm going to do is I am going to distribute this -2 through. So I'll leave the 7y alone. -2 and y. -2 and -4. Bring down my greater than sign. And this side is as simple as this can get for the moment. All right. On the left, I can combine some terms here. So 7 minus 2. And on the right, again, I can't do anything else with it. Variables to one side. So if I cancel my variables on the right, then I need to cancel my numbers on the left. And once I've done that, I can add down. 5 plus 2 is 7. 7y, bring down my greater than 7. So I should get, what should I get here? 35. That's better. And it's going to be much nicer when I divide, by the way. All right. So this is an OR problem, and I'm actually going to rewrite this guy to look, I'm just going to flip this, y is greater than 2. You don't have to graph this necessarily, but this is going to include the whole thing. So if I were to do a number line here, and I have 0, 1, 2, 3, 4, 5, this guy starts at 2, open circle, and goes this way. This guy starts at 5, open circle, and goes this way, but it includes everything. It's not just where they cross over. Had this been an and problem, my answer would have just been the greater than 5 piece. But this is an or. Since I'm talking about all of it, not just where they cross over, I'm going to use the far left one here. Because that also includes the greater than 5. I don't have to list it twice. All right, the first thing we're going to do is talk about what absolute value is. If you look in your books on page 38, it talks about absolute value. Absolute value is specifically the distance away from 0. The distance away from 0. So when I have something like this, absolute value equals 2, right here, there are two answers for that. If the absolute value of a number is 2, then I have two numbers on my number line that are 2 away from 0. I have a positive 2, that is 2 away from 0. And I have a negative 2, that is also 2 away from 0. So I can basically just take the inside of this, x, and x is going to either equal what's out here or the negative of what is out there. Both of those answer that equation. Those are both solutions. If I were to plug them back in, the absolute value of 2 equals 2. Yes, that is true. The absolute value of negative 2 equals 2. Also true. So when you start getting to absolute value equations, you see that you're going to have two answers because you have two sides of that number line that are going to be the same distance away from 0, as long as the absolute value is greater than 0 to begin with. And so this is easy. We have just a variable and a number. When you do an absolute value equation, you have to consider both sides. So we have the absolute value if x is greater than or equal to 0, and the negation of it if it is less than 0. Absolute value pretty much makes everything that's inside of it, when you take it out of the absolute value, it makes it positive. So when you're solving an equation, the first thing you want to do is get that absolute value by itself. Move everything away from it that is not inside the absolute value. And then once you have your absolute value by itself, you're going to literally set up two equations because the inside could equal the positive or the inside could equal the negative. Those are both the same distance away from 0. Once you set up your two equations, you're just going to solve it. Now, there are times we're going to do some where some of your answers may not work. If you have a variable on the outside, you could have what's called an extraneous solution. A solution that works when you do just the basic number crunching, but when you plug it back into the absolute value, it actually causes a problem. The first kind we're going to do does not have extraneous solutions. It looks like this. So my first step is to get the absolute value by itself. Is my absolute value over here by itself? Yeah, there's no number adding or subtracting. There's no number multiplying or dividing it, right? So my first step is done. Now I'm going to take the inside of this absolute value, the x plus 5. And I am going to set it equal to this guy out here. I am also going to take that same piece, the x plus 5, and I'm going to set it equal to -9. Because if I put the absolute value of 9 in there, or the absolute value of -9 in there, it will still equal +9. And so I have to count for those two scenarios when I solve these. And then it's basic solving. This is exactly what we did, last couple sections here, solving equations. I'm going to subtract my 5 over. It's going to cancel. I get x equals 4. I'm going to subtract my 5 over. It's going to cancel here. I will get x equals -14. And so I have two answers. X can either equal a -14 or a +4. Both of those will work. If you plug it back in, -14 plus 5 is -9. The absolute value of -9 is 9. 4 plus 5 is 9. The absolute value of 9 is 9. Okay? And so you are going to consider the two possibilities that happen. There are going to be scenarios where you do have things on the outside. And so if you do, like in this example, you will want to get rid of everything that's on the outside first before you set up the two equations. If not, then you could possibly solve the wrong way. In a case like this, you would actually solve incorrectly if you set up the two equations first. So I want to get rid of everything that's not inside my absolute value. That would be that -8, subtraction of that 8, and the multiplication that's happening with this 2. So I am going to, first of all, get the absolute value by itself. I'm going to add my 8 over. All right. Just like in a normal equation, it would cancel. I'm left with 2, absolute value of 3x minus 12 here. And I'm left with 24 plus 8, which is 32 here. I still do not have the absolute value by itself. So I need to divide both sides by this 2. It's going to cancel here. And I have the absolute value of 3x minus 12 equals 16. Now I have the absolute value by itself. Now I can set up two equations. I am going to take the inside, 3x minus 12, and set that equal to 16. And I am going to take the inside, 3x minus 12, and set that equal to -16. I am accounting for both possibilities. And then I am just solving. For both of these, I will add 12 and divide by 3. So I'm going to add 12 here. I get 3x equals 28. We're going to get a fraction here. So x can equal 28 thirds. It does not reduce. On this piece, I am going to add my 12. 3x is going to equal -4. Again, I am going to get a fraction. X can equal -4 thirds. I have accounted for both scenarios. I get two answers here. Two answers. So you may come across one like this. The absolute value of 2x plus 5 equals -4. Is the absolute value by itself here first? Yes, it is. Will my absolute value ever equal -4? Why not? Yeah, absolute value is always positive. It specifically indicates distance from 0. Distance is always positive. So when you come across one like this, once you get the absolute value by itself, and hear me say that because it's possible you could get one that equals a negative number, but it could have a negative in front of it. Like, let's say this looked like this. That's actually possible because I don't have my absolute value by itself yet. And when I do have it by itself, it will equal a positive number because I am dividing by a negative, right? So it's only after you get the absolute value by itself that you can determine whether or not you can find a solution here. But once it's by itself, like this is, I don't even have to work anything out. I can immediately say, there is no solution to this because there will never be a time when the absolute value equals a negative number. That is not possible. All right, so that's one case where you could have something that you immediately see, we're going to have a problem. You also have cases like this where you have a variable on the outside. All right, is my absolute value by itself? Yes, I am immediately ready to set up two equations. So I am going to do exactly what I've done before. Inside equals exactly what it gave me. Then I'm going to say the inside equals the negative of what it gave me. Do you see what I did there that's different? I had a binomial, a plus or minus out there. So I need to do the negative of the entire thing. I put parentheses around it to account for that, okay? Once I've done that, I'm going to solve. So I'm going to, on the left-hand side here, get my variables to one side. If I cancel the variables on the right, then I need to cancel my numbers on the left. Add down 2 and 8, give me 10x. 3 and -9 give me -6. And then I'm going to divide that 10 out. Reduce it, 6 over 10 reduces to 3 over 5. That's one of my potential answers, all right? On the left-hand side, on the right-hand side, I'm going to distribute that negative, all right? So I have 2x plus 9 equals -3 plus 8x, all right? Again, variables on one side. If I cancel over here for my variables, then I need to cancel on the other side for my numbers. Add down, -6x equals -12. Divide both sides. And x equals 2. Anytime you have a variable on the outside, you need to plug these back in to make sure they both work. All right, so I need to go back to my original problem and check these two answers. I'm going to say 2 times -3/5 plus 9 equals 3 minus 8 times -3/5. And I'm going to check that to see if it actually works, all right? When you check it, obviously, you have to get common denominators and all that good stuff, right? So I have -6 over 5 plus this guy needs to be over 5. So I'm going to say 45 over 5. Over here, I'm going to get 3, negative and negative. That's going to be plus. And I am going to get 24 over 5. And again, we have to make this 3 over 5. So this will become 15 over 5, right? Inside here, absolute value of 39 over 5 equals 39 over 5. Is that true? Yeah. Yes. So x equals -3/5 is one of my answers. I am going to do the same thing with this answer right here. 2 times 2 plus 9 equals 3 minus 8 times 2. 2 times 2 is 4, right? Plus 9. That's going to be absolute value of 13. 3 minus 8 times 2 is 16. What is 3 minus 16?
-13.
Does the absolute value of 13 equal negative 13? No. That means this is an extraneous solution. It does not work when I plug it back in, which means the only solution I actually have for this is that one. Even though when I worked it out, I got 2 answers, when I plug it back in, one gives me a true statement, one gave me a false statement. Now, this may not always happen. Sometimes they will both work. Sometimes one of them will work. Sometimes none of them will work, okay? So when you have something like an absolute value with a variable on the outside, you do need to go back in and say, does it actually work? Even though I found the answer, does it work? If it works, it's a solution. If it does not work, it is considered what's called extraneous, and you are not going to count it as one of your solutions. So in this case, you would have one and only one answer.